Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters method. So I'm going to show you how to solve the differential equation using variation of parameters method in three different ways. So in this video, we'll just see the part 1. Okay, so let's get going. Solve y double dash plus y dash plus 5y dash plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x, or d square plus 5d plus 6 into y equal to e power minus 2x secant square x of 1 plus 2 tan x using variation of parameters method. So we are given a differential equation of order 2. Given differential equation, y double dash plus 5y dash plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x. Consider as equation number 1. We can write y double dash as d square y by dx square plus 5 into write y dash as dy by dx plus 6y equal to the RHS part, which remains the same. Now we can write d square y by dx square using differential operator d. So you'll get d square y plus 5 dy plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x. Now take y common from all the three terms of LHS, then we'll get d square plus 5d plus 6 into y equal to e power minus 2x secant square x of 1 plus 2 tan x. Consider as equation number 2, which is an operator forms f of d into y equal to some function of x. Where f of d equal to d square plus 5d plus 6 and r of x equals to the RHS part. Okay, now let's write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square plus 5d plus 6 into y equal to 0. Consider as equation number 3. Now we'll find the solution to the homogeneous equation using the auxiliary equation and later using the
solution of homogeneous equation, we'd find the general solution of equation 1 and 2 because 1 and 2 are same equations.
Coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 5d plus 6, right? Let's replace the differential operator with m, so that we'll get f of m equal to m square plus 5m plus 6. Then the auxiliary equation becomes m square plus 5m plus 6 equals to 0. Now we need to find the roots to this equation. We can write 5m as 2m plus 3m. Now take m common from the first two terms, we'll get m times m plus 2. Now take 3 common from the next two terms. Now take m plus 2 common, we'll get m plus 2 into m plus 3 equal to 0. Equate each factor to 0. From m plus 2 equals to 0, we'll get m equal to minus 2, and from m plus 3 equals to 0, we'll get m equal to minus 3, right? From this, we'll get m equal to minus 2, minus 3, which are the roots of the auxiliary equation. We know that when two roots, say m1 and m2, are real and distinct, here the roots are real and distinct. When two roots are real and distinct, then the solution of homogeneous equation looks like one constant into e power 1 root into x plus another constant into e power another root into x, right? Then the solution to our problem, equation 3 will be y equal to c3 e power minus 2 into x plus c4 e power minus 3 into x. See, I am taking c3 and c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution, right? This gives us y equal to c3 e power minus 2x and c4 e power minus 3x, which is the solution to our homogeneous equation. Now, using this solution, we'll write the general solution of our given problem. Let y equal to, now replace c3, c4 constants or parameters with functions of x, say a and b. Then we'll get y equal to a e power minus 2x plus b e power minus 3x. Be the general solution of 1 and 2. Where a and b are functions of x, right? See, we are saying that y is the general solution of equation 1 and 2. So we can say that y is the solution of equation 1 so that y satisfies equation 1, right? Now we'll find y dash and y double dash. We have y equal to a e power minus 2x plus b e power minus 3x, right? Let's find y dash. Y dash equals to a e power minus 2x whole dash plus b e power minus 3x whole dash. Here we are going to apply uv whole dash formula, which is equals to u dash v plus v dash u, right? This gives us a dash e power minus 2x plus a into e power minus 2x whole dash plus b dash e power minus 3x plus b into e power minus 3x whole dash. This gives us a dash e power minus 2x plus a of derivative of e power minus 2x with respect to x is minus 2 e power minus 2x plus b dash e power minus 3x plus b into derivative of e power minus 3x with respect to x is minus 3 e power minus 3x, right? This gives us a dash e power minus 2x plus into minus minus 2a e power minus 2x plus b dash e power minus 3x plus into minus minus 3b e power minus 3x, right? Again, this gives us, I'm going to just remove the brackets, then I'll get a dash e power minus 2x minus 2a e power minus 2x plus b dash e power minus 3x minus 3b e power minus 3x. Now write the terms involving a dash and b dash. We'll get a dash e power minus 2x plus b dash e power minus 3x. Now write the terms involving a and b. We have minus 2a e power minus 2x minus 3b e power minus 3x. Let a dash e power minus 2x plus b dash e power minus 3x equals to 0. Let a dash e power minus 2x plus b dash e power minus 3x equals to 0. Consider as equation number 4. So that while finding y double dash, a double dash and b double dash will not appear, right? Now y dash becomes 0 minus 2a e power minus 2x minus 3b e power minus 3x, which gives us y dash equals to minus 2a e power minus 2x minus 3a e power minus, it's b, right? E power minus 3x, right? We got y dash and we have y. Now we need to find y double dash. We have y dash equals to minus 2a e power minus 2x minus 3b e power minus 3x, right? Let's find y double dash. Y double dash equals to minus 2 of a e power minus 2x whole dash minus 3 of b e power minus 3x whole dash. This gives us minus 2 of, here we need to apply ub whole dash formula again. This gives us a dash e power minus 2x plus a of derivative of e power minus 2x or e power minus 2x whole dash minus 3 of b dash e power minus 3x plus b of e power minus 3x whole dash, which gives us minus 2 of a dash e power minus 2x plus a of derivative of e power minus 2x with respect to x is minus 2 e power minus 2x minus 3 of b dash e power minus 3x plus b of derivative of e power minus 3x with respect to x is minus 3 e power minus 3x. This gives us minus 2 of a dash e power minus 2x plus into minus minus 2a e power minus 2x minus 3 of b dash e power minus 3x plus into minus minus 3b e power minus 3x, right? This gives us minus 2a dash e power minus 2x minus into minus plus 4a e power minus 2x minus 3b dash e power minus 3x minus into minus plus 3 3s are 9b e power minus 3x. Now write the terms involving a dash and b dash. We'll get minus 2a dash e power minus 2x minus 3b dash e power minus 3x plus 4a e power minus 2x plus 9b e power minus 3x, right? Which is required y double dash. We have equation 1. Y double dash plus y dash, 5y dash plus 6y equal to e power minus 2x secant square x of 1 plus 2 tan x, right? Now substitute y dash, y double dash in this equation. We get y double dash is minus 2a dash e power minus 2x minus 3b dash e power minus 3x plus 4a e power minus 2x plus 9b e power minus 3x, right? Plus 5 into y dash. Y dash is minus 2a e power minus 2x minus 3b e power minus 3x plus 6y. 6 of e power minus 2x plus b e power minus 3x equal to RHS part e power minus 2x secant square x of 1 plus 2 tan x, right? This gives us minus 2a dash e power minus 2x minus 3b dash e power minus 3x plus 4a e power minus 2x plus 9b e power minus 3x plus into minus minus 10a e power minus 2x plus into minus minus 5 3s are 15 b e power minus 3x plus 6a e power minus 2x plus 6b e power minus 3x equal to e power minus 2x secant square x of 1 plus 2 tan x, right? This gives us minus 2a dash e power minus 2x minus 3b dash e power minus 3x plus 4a into e power minus 2x plus 6a e power minus 2x is plus 10a e power minus 2x minus 10a e power minus 2x. Now coming to b, 9b e power minus 3x plus 6b e power minus 3x gives 15b, right? Plus 15b e power minus 3x minus 15b e power minus 3x equal to RHS part, e power minus 2x secant square x of 1 plus 2 tan x, right? Here plus 10a e power minus 2x and minus 10a e power minus 2x gets cancelled. Plus 15b e power minus 3x minus 15b e power minus 3x gets cancelled, right? This results to minus 2a dash e power minus 2x minus 3b dash e power minus 3x equal to e power minus 2x secant square x of 1 plus 2 tan x, right? Consider it as equation number 4. Now by solving equation 5. Now solving equation 4 and 5 we'll get a dash and b dash. Okay, let's solve equation 4 and 5. We have equation 4 and 5, right? By solving 4 and 5 we'll get a dash and b dash. So in order to solve equation 4 and 5, just notice the first terms of 4 and 5. We have a dash e power minus 2x in fourth equation and minus 2a dash e power minus 2x in fifth equation. In order to solve the terms involving a dash in both the equations, we need a 2 in equation 4, right? So let's multiply equation 4 with 2. Then we'll get 2a dash e power minus 2x plus 2b dash e power minus 3x equal to 0. Write with the equation as it is. Minus 2a dash e power minus 2x minus 3b dash e power minus 3x equal to e power minus 2x secant square x into 1 plus 2 tan x, right? We can cancel plus 2a dash e power minus 2x and minus 2a dash e power minus 2x. With this gives us plus 2b dash e power minus 3x minus 3b dash e power minus 3x equal to e power minus 2x secant square x of 1 plus 2 tan x, right? This gives us b dash e power minus 3x of plus 2b dash e power minus 3x minus 3b dash e power minus 3x is minus b dash e power minus 3x. This gives us minus b dash e power minus 3x equals to e power minus 2x secant square x of 1 plus 2 tan x. From this we'll get b dash equal to minus e power minus 2x secant square x of 1 plus 2 tan x by e power minus 2x, minus 3x, which is a required b dash. Now by substituting b dash in equation 4, we'll get a dash. We have equation 4 a dash e power minus 2x plus b dash e power minus 3x, right? We can write this as a dash e power minus 2x equals to minus b dash e power minus 3x, right? Now substitute b dash, we'll get minus of minus e power minus 2x secant square x of 1 plus 2 tan x by e power minus 3x into e power minus 3x, where e power minus 3x gets cancelled, and we'll get e power minus 2x secant square x of 1 plus 2 tan x, right? Which is our a dash e power minus 2x From this we'll get a dash equals to e power minus 2x secant square x of 1 plus 2 tan x by e power minus 2x, where e power minus 2x gets cancelled and we'll get a dash equals to secant square x of 1 plus 2 tan x, right? Therefore a dash equals to secant square x of 1 plus 2 tan x and b dash equal to minus e power minus 2x secant square x of 1 plus 2 tan x by e power minus 3x. Let's find a and b. We have a dash equals to secant square x of 1 plus 2 tan x, right? A dash is nothing but derivative of a with respect to x equal to secant square x of 1 plus 2 tan x. Now we need to separate the variables. In order to separate the variables, we'll take the differential dx to RHS, then we'll get dA equal to secant square x of 1 plus 2 tan x into dx, right? Here the variables are separable. So we can perform integration. Integral dA equal to integral secant square x of 1 plus 2 tan x into dx, right? Let f of x equals to 1 plus 2 tan x, okay? Then f dash of x will be derivative of 1 with respect to x is 0 plus 2 into derivative of tan x with respect to x is secant square x. So f dash of x is secant square x. We know that integral f of x into f dash of x dx is equals to f of x whole square by 2. We know that integral f dash of x into f of x whole power n dx equals to f of x whole power n plus 1 by n plus 1. In case of n equal to 1, we'll have integral f dash of x into f of x whole power 1 into dx equal to f of x power 1 plus 1 by 1 plus 1. We'll get f dash of x into f of x dx equal to f of x whole square by 2. Okay, this is not applicable when n equal to minus 1. Okay, applicable for n not equals to minus 1, because when n equals to minus 1, the denominator becomes 0, so that it is undefined. So just remember this formula. From this we'll get for n equals to 1, f dash of x into f of x dx equals to f of x whole square by 2. See, the integrand is of secant square x into 1 secant square x, that is, okay, say some f dash of x into f of x, but here we need some 2, right? In order to apply this formula, we need a 2 to this f dash of x. So we'll multiply and divide 2 to this secant square x and we'll get integral dA equal to integral 2 by 2 secant square x of 1 plus 2 tan x into dx, which gives us integral dA equal to, I'll take 1 by 2 outside the integral, then I'll get 2 secant square x of 1 plus 2 tan x inside the integral. Now we have exactly f dash of x, right, which is 2 secant square x into f of x 1 plus 2 tan x. Now we can apply this formula here, so that we'll get integral dA a equal to 1 by 2 into integral f dash of x into f of x dx is equals to, which gives f of x whole square, that is 1 plus 2 tan x whole square by 2, which gives us 1 by 4, 2 into 2 4 into 1 plus 2 tan x whole square, which is our a. Therefore a equal to 1 by 4 of 1 plus 2 tan x whole square. You need to write integral constant plus c1. Okay, we'll get plus c1. See, or you can write the integrand as f of x for our convenience into secant square x. I need 2 secant square x, so I'm going to multiply and divide 2 to secant square x. Then I'll take 1 by 2 common. I mean outside the integral. Then I'll get integral f of x into f dash of x dx. Now you can apply the formula easily, right? So we got a now. Let's find b using b dash. We have b dash equals to minus e power minus 2x secant square x of 1 plus 2 tan x by e power minus 3x. Here b dash is nothing but db by dx, right? Or derivative of b with respect to x equals to minus e power minus 2x secant square x of 1 plus 2 tan x into, I'm going to split the fraction numerator into 1 by e power minus 3x. This gives us minus e power minus 2x secant square x of 1 plus 2 tan x into reciprocal of e power minus 3x is e power 3x, right? Now we can write this as minus e power 3x into e power minus 2x secant square x of 1 plus 2 tan x, right? Here we are having e power minus 3x into, e power 3x into e power minus 2x. You can write it as e power 3x minus 2x. 3x minus 2x is x, so we will get e power x, right? Let's replace this with e power x. So we got b dash equals to minus e power x secant square x of 1 plus 2 tan x, right? Now let's separate the variables by taking differential dx to RHS. Then we'll get db equal to minus e power x secant square x of 1 plus 2 tan x into dx, where the variables are separable. Right? Now we can perform integration. Integral db equal to minus integral e power x secant square x of 1 plus 2 tan x into dx, which gives us integral db equal to minus integral of e power x of secant square x into 1 is secant square x plus secant square into 2 tan x is 2 tan x secant square x into dx, right? Let secant square x f of x equals to secant square x, right? We know that 1 plus tan square theta equal to secant square theta. Then we can replace secant square x with 1 plus tan square x. Then we'll get f of x equals to 1 plus tan square x, right? If f of x equals to 1 plus tan square x, then f dash of x will be derivative of 1 with respect to x is 0 plus we need to find derivative of tan square x, let it be. Okay, so we'll find the derivative of tan square x using chain rule. I'm taking some y equal to tan square x say, or t better. Let's take t equal to tan square x, or I'll write it as tan x whole square. Okay, and let sum p equal to tan x. Now I'm going to find derivative of tan square x using the chain rule. dt by dx equals to dt by dp into dp by dx. For that we need to find derivative of t with respect to p and derivative of p with respect to x, right? We have p equal to tan x, right? Then t square becomes, sorry, t becomes p square. We have t equal to p square. Okay, so now differentiate on both sides with respect to p. We'll get dt by dp equal to derivative of p square with respect to p is 2p, right? So from this we'll get dt by dx equals to, now replace p by tan x, or let's replace it later. I'll just write 2p into, find derivative of p with respect to x. We have p equal to tan x. Now I'll differentiate both sides with respect to x. We'll get dp by dx equals to derivative of tan x with respect to x is secant square x. So you'll get into secant square x, right? And now you can replace p with tan x. So you'll get 2 into tan x into secant square x. Simply 2 tan x secant square x is equals to 2 tan x secant square x, right? Or simply derivative of tan square x is, you can just write it as tan x whole square, which is equals to 2 tan x into inner derivative of tan x with respect to x is secant square x. Simple. Okay, this is the actual procedure. This is the direct way of finding. If you're really good at solving derivatives, you can just do directly. Okay, now coming to the integrand of RHS, we have e power x of secant square x, which is our f of x, plus 2 tan x secant square x, which is our f dash of x. Since we know that integral e power x of f of x plus f dash of x into dx equals to e power x f of x. Now we are going to apply this formula, right? Then this becomes integral dbb equal to minus integral e power x f of x plus f dash of x into dx is e power x f of x secant square x plus integral constant is c2. Therefore b equal to minus e power x secant square x plus c2. We got a and b. Let's now write the general solution by substituting a and b. Therefore the general solution is given by y equal to a e power minus 2x plus b e power minus 3x. Now substitute a and b, where a is 1 by 4 of 1 plus 2 tan x whole square plus c1 into e power minus 2x plus b minus e power x secant square x plus c2 into e power minus 3x, which gives us 1 by 4 of 1 plus 2 tan x whole square into e power minus 2x plus c1 e power minus 2x plus into minus minus e power x into e power minus 3x secant square x plus c2 e power minus 3x, right? Or we can write it as 1 by 4 e power minus 2x into 1 plus 2 tan x whole square plus c1 e power minus 2x minus e power x into e power minus 3x gives e power x minus 3x, which is equals to e power minus 3x plus x is minus 2x. You can replace it with e power minus 2x into secant square x plus c2 e power minus 3x. Right, from this we'll get y equal to, write the terms involving c1 and c2, we'll get c1 e power minus 2x plus c2 e power minus 3x plus 1 by 4 e power minus 2x of 1 plus 2 tan x minus e power minus 2x secant square x, which completes the problem. So you'll have whole square here, okay? So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.